All right, welcome back to the last lesson of Unit 3. We are going to be looking at the discriminant, okay? That's a new term that you probably have not heard before. I'll show you that in a second. Before, again, the new lesson, I would like you to solve this quadratic equation using these three different methods that we've learned so far, okay? And good luck. Okay, so by plugging the values of a, b, and c into the quadratic formula and follow the steps, you should get 1 and -7/2 as your answers. Okay, hopefully that's what you got. Now go ahead, try method number 2. Okay, so here is how you do it by completing the square. You factor the leading coefficient. This time, this middle term is a 5, so you actually end up with a fraction in the middle. So this time is not as easy. I just want to go through the steps one more time with the completing the square because it's longer than the other two. You take this this coefficient in front of x, take 5/2 divided by 2, you get 5/4. If you square 5/4, you get 25/16, and that's why we have the plus 25/16 and minus 25/16. We recall these first three terms will be a perfect square, so this is right here, 2 times x plus 5/4 squared. This number, 5/4, is always half of the coefficient in front of x. And you want to take this -25/16 out by multiplying by 2 right here, so you get -25/8. I know that it was going to be denominator of 8, so I changed 7 or -7 to -6/8. Added these two, subtract these two together and then move it to the right. I got 81/8 divided by 2, 81/16. Square root both sides, you get plus minus. Don't forget it's plus minus. And then you square root 81/16. Square root of 81 is 9. Square root of 16 is 4. And then just subtract 5/4 from the left. And move it to the right. So you got to do positive 9/4 minus 5/6 and negative 9/4 minus 5/6, which you get these two answers. Okay, finally try the factoring method. So factoring method, well, you just need to factor, so I did it with guess and check. This is what you should end up with. Okay, again, regardless of which method you use to factor, you should get this. And then you just need to set each set of brackets equal to 0. Then you should get either -7/2 or 1, just like the first two ways of solving. Okay, so that's how you solve using three various methods. Or number 2, so I would like you to solve these three questions using the quadratic formula. And it says determine the nature of roots. I'll explain to you what that means in a second, but I want you to solve these three questions first using quadratic formula. Okay, so go ahead. Okay, so if you apply the quadratic formula for these two quadratic equations, this is what you should get. For the first one, you should get -1 and 8/3 as your answer. For the second one, you should get x equals to 1. For the third question, you should not have any solution, and because, we cannot square root -79. Okay, so that's how you would solve the equations here. Now, the question also asks you to determine the nature of roots, okay? So, there are three options for quadratic equations. You either have one real root, two real roots, or no real roots. I think you probably guessed it right here already. We have two answers here. So, in this case, we have two real roots. And in the second case, we only have one single answer. We call this we have two identical real roots actually, but you could just say that we have one real root. And for the third one, well, we don't have an answer there. This is not, we don't have a real root here, okay? So this is an answer, but it doesn't really work for real numbers. So we have no real roots. Okay? So if you think about from what you did, okay, how can we actually tell without solving? Well, I noticed something here, okay, so inside the square root right here, this is a positive number. And if I have a positive number, that means when I take the square root, I actually get a value that's not a 0, which means when I add and subtract, this particular number, I'll get two different results, and that's why I have two answers right here, right? Whereas the second case, you can see the radicand here is a 0. And regardless of whether I add or subtract 0, I won't get the different value. And that's why I only have one single answer, because really I end up with 6 plus 0 divided by 6, or 6 minus 0 divided by 6. But notice 6 plus 0 and 6 minus 0 is the same thing, right? And that's why we have one single root. Whereas the third case, I have a square root of negative number. I can't square root negative numbers, and that's why we don't have any solutions, because this is not valid, right? This is not defined. So, whatever the value is for the radicand, it matters, and we can actually use that to determine the nature of the roots, and that is what we call the discriminant. Okay, notice b squared 4ac is part of the quadratic formula. It is the radicand, right? Inside that square root right here, you can see here's a quadratic formula, and b squared minus 4ac is right there. So we call that the discriminant. Okay, we call that the discriminant, and well, we call it discriminant because it discriminates between the possible solutions. So let's just do a quick recap. We would have two real roots if the discriminant b squared minus 4ac is greater than 0. We would have exactly one real root when the discriminant b squared minus 4ac is equal to 0. And we would have no real roots when the discriminant b squared minus 4ac is less than 0. Okay, so that's the summary. And now we're going to take that and check how many real roots we would have in these two cases. I'm actually going to let you try it, okay? It's not very difficult. Again, you just need to identify A, B, and C's and then plug it in, okay? Give it a try. Okay, so if you, again, identify the values of A, B, C, and then plug it in, for the first example, you should have negative 80, which is less than 0. Again, going back to the summary right there, whenever the discriminant is less than 0, that means we have no real roots. Again, because we cannot square root negative numbers. For the second example here, one thing you need to do first is to move the 3 to the left. Okay, so again, anytime you're solving quadratic equations, you need to make it equal to 0 first. Okay, so once we've done that, then again, you just plug the values of A, B, C into the discriminant formula right there. You should end up with 37, which is greater than 0. That means two real roots in this quadratic equation. Okay, so it's not too difficult. It's quite straightforward. Now I'm gonna show you something different here. We are gonna solve for k. Okay, so it says determine the values of k so that this equation would have either two real roots, one real root, or no real roots. Okay. So we're looking for the value of k here. So again, when you see this, that means we need to use the discriminant to differentiate, right? We need to use the discriminant to solve this question right here. So again, discriminant is b squared minus 4ac. Now because we want two real roots, so we want this to be bigger than 0. So now we plug in the values of a, b, and c. So b is negative 5 minus 4 times a, which is 2. Now for the value of c, we don't actually have a value. It says c is k, so that's what I'm going to do. I'm going to put k as c. And then this is greater than 0. So now I need to evaluate this when possible. So negative 5 squared is 25. Minus 4 times 2 is 8. 8 times k is simply 8k. And this is greater than 0. To solve for k, I need to move the 25 to the right. So I end up with negative 8k is equal to negative 25. Finally, to solve for k, I need to divide both sides by negative 8. Recall, I think I mentioned this to you in class, whenever you divide inequalities, whenever you divide numbers or multiply numbers, okay, let me rephrase that. Whenever you multiply or divide negative numbers, when solved in inequalities, you need to flip the inequality sign. So this was greater than, so because to solve for k, we need to divide it by negative 8. So you see, we are dividing by a negative number. We need to flip. Okay, you see, I'm flipping the inequality sign. Okay, so then this becomes positive 25 over 8. Okay, negative 25 divided by negative 8 is just simply positive. Okay, so that's part A. Part B is very much the same thing. So we want one real root. So in this case, what we want is b squared minus 4ac is equal to 0. Okay, so since it's the same quadratic equation, really we'll get the same thing. The only thing that's different is this was a greater sign, and we are going to change that to equal sign. So we have 25 minus ak is equal to equal to 0. So for k, again, minus 25 on both sides, divided by negative 8, you get k has to be 25 over 8. Finally, if you want to have no real roots, that just means the discriminant has to be less than 0. Okay, so then, once again, you need to plug in the values, and then expand. So you get 25 minus 8k is less than 0, minus 25 on both sides. And now you need to divide both sides by negative 8, which means again we need to flip the inequality sign, and you get k has to be greater than 25 over 8. Okay, so that's how you do these kind of questions. For this practice question, it's kind of similar. There's a little thing that you need to watch out for, and I'll show you right now. Okay, so it says determine the values of k so that x squared minus kx plus 9 has 2 real roots. So in this case, we know that b squared minus 4ac has to be bigger than 0. So you was like, oh, Mr. H, that's the same thing. What's the difference here? Okay, so now let's plug in the values and let's see what happens. Now in this case, b is simply negative k. Minus 4 times a is 1, c is 9, this is bigger than 0. Negative k squared is actually k squared, minus 4 times 1 times 9 is 36. So for this, I need to move 36 to the right, and then I would have k squared is bigger than 36. Alright, this is where the difference occurs, okay? Well, then you might say, okay, well, Mr. H, well, what's so different about this? What I need to do is just square root both sides, and then I say, okay, well, square root of 36, I need to put plus minus 6, and then I'm done. Wrong, okay? Unfortunately, it doesn't work that way, okay? What you need to think about is this. If you say that k is greater than 6, sure, because 7 squared is definitely bigger than 36, that's fine. But if you say k is bigger than negative 6, well, then let's see what happens. Let's pick a number that's bigger than negative 6. Let's pick negative 5. Right? Negative 5 is definitely bigger than negative 6. Now, if I plug in negative 5 into k, well, then I get negative 5 squared, which is positive 25. But clearly, 25 is not bigger than 36, right? Again, if I plug in negative 5, because negative 5 is bigger than negative 6, and I do this squared, this is actually 25, but 25 is not bigger than 36. Okay, so really what happened here is k, when you solve inequalities for like quadratics, it's a little tricky, okay? And I'll go into more details next unit, but for now, the only kind of quadratic inequalities you'll deal with is this. It's just something squared is bigger than or smaller than a particular number. What you need to do is you square root both sides, you get two numbers, and then you just need to do one extra step. You need to think about it, right? Bigger than 6, this is going to work, so that's fine. But bigger than negative 6 is not going to work. Instead, it's actually going to be less than negative 6, right? Let's pick a number. Let's say negative 7. Negative 7 is definitely less than negative 6. Negative 7 squared is actually 49. 49 is bigger than 36, so this one does work, right? So this is actually the solution right here. Okay, so I'll let you try part B and part C and see how you do. Okay, so for part B, again, if you follow the same procedure, one real root means equal to 0, the discriminant is, and then you'll get to this situation, k squared is equal to 36. In that case, you could actually say that k is equal to both positive, or I shouldn't say both. K could be equal to positive 6 or negative 6. Okay, so that's fine. You don't need to worry about the inequality sign because it's equal sign, so it's easier to deal with. Okay, part C, go ahead. All right, part C, so same thing, follow the same steps. No real roots means the discriminant has to be less than 0, so you'll get into this situation where k squared has to be less than 36. And again, what you need to do is think about, okay, so here's 6. Now I need to think about picking a number less than 6, 5, let's say. 5 squared is definitely less than 36, so this is going to work. For -6, again, pick one side. You pick either bigger than -6 or smaller than -6 and just try it. So k bigger than -6 is going to work because, again, I pick a number that's bigger than -6, let's say -5. -5 squared is positive 25, and 25 is definitely less than 36, so that also works. Okay, so you just need to be careful when you solve inequalities. Make sure you try a couple numbers and see how that goes, see if it works. Okay, that's it. That is the end of Unit 3. Okay, let me know if you need some help. Make sure you do lots of practice questions. Okay, so because really the first units, they are just skills. Okay, and they are the skills that you need for next unit. Okay, so yeah, practice lots. Okay, let me know if you need help. Good luck.